This is Mr. Beck Does Your Homework. This is AP Physics, homework 9.2, question number 4. A proton and an electron in a hydrogen atom are separated on the average by about 5.1 times 10 to the minus 11th meters. So that usually is going to be my r, is my separation, is my distance of 5.1 times 10 to the minus 11th meters. What is the magnitude of the electric field set up by the proton at the location of the electron? So I want to find my E field strength. The value of the Coulomb constant is. Now, one way to get E field strength would be my force divided by my charge. So what I could do, since I know that my charge on my proton is 1.6 times 10 to the minus 19th coulombs, that's my charge on a proton, that's my charge on an electron, every proton, every electron, whole universe. Protons are positive, electrons are negative. So I know the charge on one. I could figure out my force equals K Q1 Q2 over r squared, and then take that force and divide it by the charge of one of them. But if I do that, then I'm dividing by the Q2 anyway. So since E equals F over Q, that's the same thing as K Q1 Q2 over r squared divided by Q, and that's going to get rid of that. So that leaves me with KQ over r squared. So I know that my electric field strength is either F over Q, or it's also K times the charge that is there divided by the distance to the point I'm interested in squared. So if I have a positive charge here and I've got this location in space some distance r away, well, that's going to be the formula I use, KQ over r squared, to tell me the electric field strength there, even without the electron there. So if I use KQ over r squared, there's Q, there's r, I'm looking for E, and I know K is, what, 8.99 times 10 to the 9th. So two ways of getting electric field. It's either force per charge, or it's KQ over r squared, Q being the charge that is there, as opposed to the other charge.